Okay, so in a certain neighborhood, 100 households, 48 households have a dog as a pet. Of these, 32 also have a cat. Given that the household has a dog, which probably that also has a cat. So what kind of is this? This is a, if you have a condition, right, it's a conditional probability. So we got to first recognize that, right? We want the probability of a cat given that it has a dog. We have extra information. So that makes it a conditional probability. So remember then that the formula, the probability of B given A, well, let's see, that's the probability of A and B. And you always divide by the probability of the condition that you have, the probability of A. So we want the probability that you have a cat, right? What's the probability that it is also has a cat given leave a dog? So that would be the probability of a cat and a dog divided by the probability of the condition, which is the dog. So just working my way through the formula.
So wouldn't it be
It actually, the order makes no difference on this and statement. So it could be either way, Sydney. So either would be the same. What is the probability that you have a cat and a dog? 48 households have a dog as a pet. Of these, 32 also have a cat. So what's the probability of having a dog and a cat? 0.32, right? 32% have both a dog and a cat. What's the probability of just having a dog? 0.48, yeah. Because 48 have a dog. And so we just divide that, and I got to be 0.67. Again, the test will say, let's write all these answers as decimals. Okay. On 7, the owner of a bookstore has determined that 80% of the people who enter the store will buy a book. Of those who buy a book, 60% will pay with a credit card. Find the probability that a randomly selected person in the store will buy a book and pay for a credit card. When you see you want to have an and, right? Buy a book and pay for a credit card, you have to decide what type of events are these. Because our and statements are either, are they independent events or are they dependent events? Because it affects, right, which formula you're going to use. You know, on the very front page we had a couple different formulas for with the and, right? Here we have for the dependent was this formula and the independent was this one. You kind of got to decide on this one. Which type of events are they? Does one affect the probability of another? And let's see, so our two events, buying a book. So, if those 80% who come to the store are going to buy a book, right? All right, now, so no matter how you pay, 80% buy a book. Okay, now, of those who buy a book, 60% use a credit card. Are those dependent or independent? Those are independent, and it's always a little confusing. You got to rethink about that. But the buying a book doesn't impact the percent that pays with a credit card. That enter the store. I mean, it's not. So they're independent events. Now, if they're independent events, that means that the probability of buying a book and paying with a credit card, right? Well, that's just going to multiply those together. So what's the probability of buying a book? 0.8. And probably paying a credit card. So 0.48. Okay. All right. So again, those are independent events. So you have to determine. We have a few more dependent ones coming up. Number 8. This time we have a jar. 4 red marbles, 3 blue, 5 green. 2 marbles are drawn from the jar, 1 at a time without replacement. So that without replacement is pretty important on this. What is the probability that the second marble is red, given that the first was blue?
So that means there are 2 blues. And
Okay, so what's the probability that the second marble is red, given that the first is blue? Now let's see, how should we handle this one? I thought maybe we could sneak this one in, but probability that the if we do, this is really another conditional one, right? Probably that the second is red, given the first is blue. We want the probability that the second is red, given that the first is blue. Now, if we use our conditional probability formula, right, it's the probability that we have a blue and a red, that the first is blue, and that the second is red, divided by the probability of the first is blue.
So it's just 4 of them.
yeah, 0.25.
4 over 11.
All right.
Why don't we pick up earlier?
So
I was thinking of it.
this right here is what? The first being blue and the second red is this, right? So this would be, we have 3 over 12 times 4 over 11. We divide that by the first being blue, which is 3 over 12. As Bailey said, the answer is 4 over 11, which is how much? .36. So again, a conditional probability. What? You could have. Yeah. Well, we could have, I guess, because this, in the end, right, we won the probability that the second was red, given that the first was blue. So when you have actual numbers, we could have skipped to that. All right, on 9, an individual plays on a slot machines are independent. So we're given that they're independent, right? That one loss doesn't affect your next one's loss, right? And of course, this is always people's draw to slot machines. Is that if I keep losing, I know that the win's coming closer, right? And I got to be closer. But they are independent. So just because I've lost 100 times in a row doesn't mean the next time I'm going to win. The probability of winning on any play is 0.38. What's the probability of winning 3 plays in a row? So we want the probability of 3 in a row. So that means the probability of the first. Now they're independent, right? So if they're independent, we can just multiply these together. That's always the key part. Probability of the first times the probability of the second times the probability of the third. So that means that it's going to be 0.38 times 0.38 times 0.38, which is 0.055. I've written down.
Not very good.
Okay, so yeah, 3 in a row is not very good. That would be that's about 5 times out of 100 if that was the correct. On 10, suppose that the slot machine is played 5 times in a row. What is the probability of winning at least once? Well, again, how do you do at least once? That is 1 minus the probability of the complement, right? What's the complement at least once?
Not at all.
Not all, right? So probability of not winning at all. Okay, so that means that's 1 minus. Now, how many do the probability of not winning? What's my probability of not winning each time? 0.62, right? It's 1 minus 0.38. So it's 0.62. I'm doing it how many times? 0.62 times 0.62. How do I know I can just multiply them together? What's the key part of that? What kind of events are these? They're independent events, right? Since they're independent, I can do it, just multiply those together. So that actually that's 1 minus 0.62 to the 5th. So 1 minus 0.62 to the 5th. 0.908, 0.91. So I have a pretty good probability of winning at least once, don't I? If I play this game 5 times in a row.
Okay, so how did you get the 0.62?
So the 0.62, the probability of not winning, right? If I have a probability of winning is 0.38, it's 1 minus that. So 1 minus 0.38 is this 0.62. Okay, so my probability of winning is 0.38, so probably will not winning is 0.62. All right. 11. The Roman alphabet consists of 5 vowels, along with swimming constants. Gregory needs to make up a computer password containing 7 characters. He wants the first 6 characters to be alternate, constant valve, constant valve, constant valve, with repetitions allowed. Then he wants to use a digit for the 7th character. How many different passwords can he make up? All right, the very first digit, how many choices does he have?
21.
21. Second digit, constant valve, constant valve, constant, and another valve. And right, we can allow repetitions. If we couldn't allow that, that would change it, wouldn't it? But I can allow that. Now, what's the last one going to be? The 7th digit. And he's got a digit, and there's 10 digits. So we're going to multiply all that together. Actually, we got what? 21 cubed times 5 cubed times 10. 21 cubed times 5 cubed times 10 is, I got 11,576,250. On B, if he makes up a password at random, what's the probability the password is banana7? So the probability of getting that password is what? 1 out of 11,576,250. And so that would be how much? Very, very small number. I left mine in scientific notation. I got 8.6 times 10 to the negative 8. So very small chance of getting that. Okay, on 12. On 12, we've got Kate offers 24 different types of dessert. And how many ways can 5 of them be chosen for a banquet if the order doesn't matter?
Ways. Okay. Not
Oh, that's what ways. Wow.
how many words get that?
All right, so the key statement on this is what? Order doesn't matter. What's that tell me?
It's a C and not a P.
It's a combination, right? Not a permutation. So it's a combination. Now, what number goes first in my combination? 24. Out of 24 different types of desserts, I want to choose 5 of those, right? And again, I'll let you just put this in your calculator using the shortcuts, or you could use the formula. Make sure you practice either way. 24, math, probability, combination number 3, and 5. There are 42,504 different ways . 42,504 different ways you can come up with that. It would be, so it would be 24 factorial over 5 factorial times 24 minus 5 factorial. So that'd be the formula, and that will be on the formula sheet if you want to do it that way as well.
Is the 5 underneath that?
Yes, if you just did formula, that would be like that. Okay. All right, was good? All right, number 13. All right, let's see. If there were 30 students in last semester's statistics class, of these, 6 received a grade of an A, 12 a grade of a B. What's the probability that a randomly chosen student received a grade of an A or a B? When you see the or, what do you have to decide about the events? Are they mutually exclusive? Are these events mutually exclusive? Why?
Because you can't have an A and a B.
Cannot happen at the same time. You can't have both an A and a B. So our answer to that is yes. Which means which formula do we use? An A or a B would simply just be the probability of A plus the probability of a B. Alright, so you got to ask yourself this question first. I get yes, I can use that. So what's the probability of getting an A in this class?
6.
6 out of 30.
Plus 12.
12 out of 30.
This is 8.
So 18, and that should make sense that 18 out of 30 had an A or a B, right? I mean, think about it that way. And so that would be 0.6. Alright, so 0.60 on that. Alright, on 14. Let S be the event that a randomly selected college student has taken a statistics course, and let C be the event that the same student has taken a chemistry course. Probability of S is 0.4, probability of C is 0.3, and probability of S and C is 0.2. Find the probability that the student has taken a statistics or chemistry course. Again, you see the or, what do you have to ask yourself?
Are they mutually exclusive?
So first question you ask yourself, are these events mutually exclusive? And what's your answer to that?
Because you can have them.
Yeah, so this time it's no, because you can take both stats and chemistry, right, and take it at the same time in the same semester, so that would be no. Now, there may be, remember, if I give you a similar question on the test, there may be some courses you couldn't take at the same time, right? So I probably couldn't take, let's say in the high school level, I could not take Algebra 1, Algebra 2 at the same time. So some courses I couldn't, right? Those will be mutually exclusive. This one is a no, so that means that I have to use the formula that the probability of a statistics or a chemistry is probably a stats plus probability of chemistry minus probability of both. Because they're not mutually exclusive. I have to change that formula, unlike the one above, which were. So the probability of stats is how much? This would be 0.4 plus 0.3 minus 0.2. Easy math. Answer is 0.5. Okay, so on B, probability that a student has taken a stats course because the student has taken chemistry. So conditional, right? I want the probability of a stats given the chemistry. So let's see, that's the probability of stats and chemistry divided by the probability of chemistry. It's always divided by the condition, right?
Okay.
So my top number is how much? Stats and chemistry, right, is 0.2. The probability of chemistry is
3.
just chemistry is 0.3. So 0.2 divided by 0.3 is 0.6, 2/3, 0.67. So that's a conditional. We're given extra information to help us with that probability. Okay. 15. Suppose that startup companies in the area of biotechnology has probability of 0.2 to become profitable, and that those in the area of information technology have probability of 0.15 to become profitable. A venture capitalist invests in one firm of each type. Assume that companies function independently. That's important. So what's the probability that both companies become profitable?
Should you just add it up again?
Both would be a what statement? An or and an and. Which one is in both? An and. I want both the probability that the bio is profitable and the information is profitable. Now, what formula do I use for this?
Just the normal.
Are they independent?
Yes.
Yeah, I mean that's the question you have to ask. Are they independent? Yes. If they're independent, then I can do it with these two.
What does that say? I'm sorry.
It's
This
bio.
bio and information.
You both fine.
Yeah, so it's basically the probability of the bio being profitable times the probability of the information company being profitable. So do we know the probability of the bio? This is 0.2. The probability of the information, 0.03. Alright, so both companies making money is not very high in this case. What's the probability of at least one of the two companies become profitable? Alright, now, again, I got at least one.
You just gave me that.
How do I deal with at least one?
One
Okay.
minus.
Yeah, so this would be the probability of at least one
Biscuit. It's like a little one. It's like a fifth time.
would be 1 minus the probability of the complement. What's the complement? Yeah, none of them, right? None are not being profitable. None not be profitable, something like that. The complement. Okay, so how am I going to find the probability that none of them are profitable?
You would subtract it by 0.35.
Well, okay, so right, none would be that the probability of both the probability of the bio is not profitable, right? Times the probability that the information one's not profitable. Let's see. So it'll be 1 minus. What's the probability of the bio not being profitable? 0.8 is the 0.8 chance of not being profitable. And the information is 0.85 is not being profitable. So I got that to be 0.32. 0.32. So again, at least one is 1 minus probability of the complement of at least one, which would be none of them are. Okay, 16. A process manufactures microcircuits that are used in computers. 12% of the circuits are defective. Assume that 3 circuits are installed in a computer. Denote a defective by D and a good by G. List all 8 items in the sample space. Now, so all the possible things we can have. So we're doing 3 circuits in a computer, right? So the first one could be what? Right, we have the very first one, and I'll do a tree. You don't have to do this necessarily, but you have a defective or a good one, the first one. Then the next one could be defective or good, defective or good, and the last one could be good. Now, what's it mean list out the sample space?
List of possibilities.
All the possibilities, right? And so if you just go through your tree, right, I'm just going to go work it down. And again, the order doesn't matter. But I could have all 3 defective. Or I could have defective, defective, good. I could have, that takes care of this top one, right? Defective, good, defective, or defective, good, good. Then I could go down to the good first. Good, defective, defective, good, defective, good. Or good, good, defective, or good, good, good. Make sure it looks like G's and not 6's. So that is the sample space, right? Sample space always means if you have to list it out, you have to list all possibilities. And obviously I'd have to give you one that's possible to do because sample spaces can get very large very quickly. Okay, so alright, so there's sample space. Last page here on B. What's the probability that all three circuits are good? Okay, so I need the probability, right, of circuit. The first circuit's good, and the second is good, and the third is good.
Why can't you make it easy?
Make it easy?
Like 1 out of 8.
Why do we gotta do that?
Well, let's see. Probably all three circuits are good.
Can we not just put 1 out of 8?
No.
Just go back and look.
Why?
Well, first off, are these events independent?
Yeah.
They're independent events, right? Now, what do we know about the good and the bad about these? In other words, what percent? 12% of the circuits are defective. Right now. So what? Well, you gotta be careful on this one, right? What did you say? The 1 out of 8. What's the 1 out of 8 mean?
All 3 are good.
They chose that all three are good, right? But the percent of each one being good is how much? Well, it's 88%, right? So any one I pick, I have 80% of it being good. Follow me on that? All right. So if we think of it this way, and if we think of these being independent events, how do I find probably the first good and the second good and third good? I'd multiply them, right? So it's going to be 0.88. First good is 0.88. The second being good is 0.88. And third being good is 0.88. So 0.68. All right, now. Ooh. All right, so C. Should have more room for this one, I think. Okay, now it says that. Ooh. All right. So I guess will Thursday work for the test?
Yep.
Yes, we're all okay with that. Sooner that works okay for you guys. Your schedule. All right, we'll do that. We'll finish this up tomorrow. Do some more practice then.